In today's class, we are going to discuss about semantic rules with control side effects. As an example to this simple type declaration, we are going to discuss. This is one of the major question as exam point of view. So they may ask you to write SDD for simple declaration. You already know that what is a simple declaration. Say for example, int id, float abc, so something like this. So we are considering two options here, two data types, int and float. With that you can define any number of variables. So for that, this is what a production that you are going to have. There are two sections in the production. So D produce data type and followed by identifier or a variable name. Okay, so data type can be either int or float, and a variable can produce recursively any number of variables. So L comma id, and finally you can end this production by introducing id to this place. So this L1 indicating that it's just a different node compared to this node. So just to have a difference between these two, we are giving a suffix L1, otherwise both are one and the same. Recursively it is going to produce any number of variables with comma separated. Okay, so what is the rule section, semantic rules that you are going to write for this? As for this particular example, first let us understand how do we write the tree. D produce T and L, where L produce L and id, okay, and L produce id. So this is your simple parse tree. So for this we understand that the rule, since this is a node which is a variable which requires a data type, obviously you have to carry the value from this. So that's why you have to write the rule according to this. So for this production, the rule which you are applying is T dot type. So let us start from the bottom to make it so clear. So L produce id. So what do we do for this? You need to enter this value into the symbol table. So id dot entry, you have to call the function. So for that, add type, you are adding the type of the variable into the symbol table. So id dot entry is a pointer and its type. Where is that type holds? It is there in the inherited attribute. So L dot inherited. Both this thing you are going to store in the symbol table, and this is for the last production. Next, moving on to this production, L produce L id. So what is that rule that you are applying? L produce L id. So here there are two actions that you are performing. You are passing the value to this, and this is taking a value from the left side, and this value is coming down. So these are the actions that you are performing. So what you should do, from the root node the value should come to leaf node. So this is the one action, and also you have to add the type of this data type. Once you get the data type here, that data type along with the identifier you have to store into the symbol table. That's why you have to call this function. So both are the semantic rules. Next, moving on to these two productions, it's so simple that it is a semantic what do we call it as, values which are not inherited values. Okay, so that's why you have it is going to create a value itself. T dot type is integer and T dot type is float. It's having its own value. So T dot type is being computed with the int value, and similarly float value. Next, coming to this, the action which you are performing here is T dot type is being assigned to inherited value. So L node is going to obtain the value from this side. Okay, so L dot inherited is assigned by T dot type. That is the action that you are performing here. So when you take this subtree, here this is only one action that you are performing. When you take this subtree for the production, so this is the action that you are performing. Similarly, this is the action that you are performing. id dot entry. Okay, hope you understood this example. Similarly, you can also try for float id comma id comma id. There are three variables here. D produce TL, L produce LID, this L going to produce LID, and this L going to produce ID1. So this is the identifier 1, identifier 2, identifier 3. Three identifiers are there. In order to differentiate between these three, we have given suffix 1, 2, 3 for ID. As usual, we already know that this is the production semantic rule. T dot type is obtained with float, and this node is waiting for the value from the sibling type, have that value type, and that type is being transferred to its child. Similarly, this is being transferred to child. So once the value you obtain here, immediately this value is going to be stored into symbol table. Okay, ID3 is going to store in the symbol table. Similarly, this value is coming down here, and this identifier is going to obtain this value and going to store in the symbol table. Similarly, this in the data type has been obtained to its child, and this is having again entry to symbol table. ID1 is going to be entered into the symbol table. This is how it's going to work. Thank you.